Today, in this video, we will see stress strain diagram for mild steel ductile materials. What is ductile material? It is the property of a material to undergo considerable deformation under tension before rupture. Property of a material to undergo considerable deformation under tension before rupture. Stress strain diagram for mild steel. So, in x-axis there is strain and in y-axis there is stress. So between O and A there is limit of proportionality. This point A is called limit of proportionality. X-axis is strain, y-axis is stress, and between O and A is limit of proportionality. So in the range of OA, strain is proportional to stress. In that range of OA, strain is proportional to stress and graph is straight line. See, stress increases, strain also increases proportionally and graph is straight line. Point A is called limit of proportionality. It is the value of stress up to which stress and strain has a constant ratio. Stress and strain has a constant ratio and it obeys Hooke's law. Hooke's law is stress is directly proportional to the strain. As stress increases, strain also increases. This point B is called elastic limit. At point A, the curve deviates from the straight line and the stress strain graph from A to B is non-linear. See, this point A, curve deviates from straight line and stress strain graph from A to A is non-linear. If the load is increased beyond A up to point B, the material behaves in an elastic manner. And on removal of the load, the whole deformation will vanish. If this after this A point load increases up to point B, the material behaves as elastic limit, and after removal of the load, deformation will vanish. That means up to point B, elastic region. See this O to A, elastic region. The value of stress correspond to point B up to which the material behaves as an elastic manner is called elastic limit. Material behaves as an elastic manner is called elastic limit. See, this point B is elastic limit up to which the material behaves as a elastic. Usually this B point is very near to A and many times the difference between A and B is ignored, and therefore the elastic limit is taken as limit of proportionality. Between A and B, difference between A and B is ignored, and therefore elastic limit, see, this elastic limit is taken up to B. This C point is upper yield point. What is yield point? Yield point is the stress strain curve shift from elastic to plastic behavior. Elastic shifting from elastic to plastic behavior is yield point. When the load is further increased, plastic deformation occurs. After this elastic limit B point, when the load is increased, plastic deformation occurs. That means on removal of the load, the strain not fully recoverable. After this elastic limit point, plastic deformation occurs and strain is not recoverable. At this stage, strain is about 0.125 and stress is about 250 Newton per mm square for mild steel. Mild steel Fe 250, strain is about yield strain. Yield stress is about 250 Newton per mm square. At point C, metal shows an appreciable strain even without further increase in load. See, after this C point to D point, there is not increase in stress but strain increases. At point C, metal shows appreciable strain even without further increase in load. And this D point is lower yield point. It is the point at which yielding process vanishes. This D point is the point at which yielding process vanishes. This is indicated by wavy appearance of the stress strain graph between C and D. Further, stress and stress can be obtained by increase in load. After this lower yielding point, strain obtained by increasing the load. See, this stress increases and strain also increases. Further, stress and strain can be obtained by increasing the load. Ultimate load point. This E point is ultimate load point. See, stress is maximum at this E point. That means E point is ultimate load point. After increasing the load beyond the yield point, the stress strain curve rises till the point E. It reaches is called ultimate or maximum load point. The stress correspond to this point is also maximum. See, stress correspond to this point is also maximum and is called ultimate stress or ultimate tensile strength. The stress is about 370 to 400 Newton per mm square. At this stage, cross-sectional area at particular section start reducing very fast. This is called neck deformation and load reduces to cause further extension is reduced. At this E point, necking develop. Necking means this is mild steel bar. Consider this mild steel bar. Necking. This is necking. At this stage, cross-sectional area at particular section start reducing. This cross-sectional area reducing very fast. This is called necking. And after this, F is breaking point. As the elongation continues, see, strain increases. As the elongation continues, cross-sectional area becomes smaller Ultimately, the specimen is broken at F into two pieces. Cup and cone type ductile fracture. At this point F, there is cup and cone type ductile fracture seen. Cup and cone like this. Cup and like this. Cup and cone failure can be seen at F point. Point F is called breaking load point and stress correspond to this point is breaking stress or rupture or breaking strength of material. At this stress, strain is 20 to 25. So this is stress strain diagram for mild steel. Firstly, O and A, there is Hooke's law obeyed, and after this A and B, there is deviation in curve, and O and B is elastic region. Between O and B, elasticity is obeyed, and after this, as stress increases, strain also increases, but there is no elasticity. This region is perfectly plasticity region or yielding. After this yielding point D, stress increases, strain also increases up to ultimate load point, and this ultimate load point necking develop. After this, stress stress is not increases, but strain increases, and cup and cone failure can be seen at point F. So this is ductile material stress strain diagram for mild steel. Thank you very much.